Hi children, welcome to your home school. This is your first session of your 9th standard. That is your first chapter, number system. Children, you have seen in basics about everything. What is that? Real numbers, even numbers, odd numbers, prime numbers, what is a rational number, what is a fraction, how to add a fraction, decimals. These all we have seen. Right? So we are now perfect to start with our 9th standard mathematics. See here children, look here, this is your textbook. Okay, first let us recollect our number system. What is a number system? Number system, first we start counting with the numbers. What are the numbers children here? 1, 2, 3, we count infinitely. Okay, there is no end for this numbers. Those numbers are called as the natural numbers and is represented by the letter capital N. We have seen in the video. And next coming numbers. What are those? Whole numbers. Natural numbers is represented by the letter N. Whole numbers. What are whole numbers, children? Natural numbers including 0 are called as the whole numbers. Yes or no? All the natural numbers along with 0 are called as the whole numbers. Next numbers, integers. What are integers here? All the negative numbers along with the whole numbers. See, along with the whole numbers and also negative numbers with whole numbers, we call them as the integers. Natural numbers, I repeat here, natural numbers with the set we used to represent 1, 2, 3, 4, so on. Whereas the whole numbers, natural numbers, including 0 are called as the whole numbers. What are the next numbers here, children? Integers. Negative numbers along with the whole numbers are called as the integers. What is your next numbers we have learned? That is rational numbers. What are rational numbers, children? Rational numbers are the numbers which we can represent in P by Q form, where Q cannot be equal to 0. All the numbers which we can represent in the form of P by Q are all called as the rational numbers. Look here children, all these numbers are all rational numbers. You may see only numerator, but there is a denominator, that is 1. So look here, let me write some of the rational numbers here. Minus 3 by 2, 5 by 4, 7 by 2, so on. If you go on writing, there are infinite rational numbers. Now coming to your irrational. What are irrational, children? The numbers which we cannot represent in the form of rational are all called as irrational. Irrational numbers, what are the example here, children? Q bar. Just Q bar means it's not a rational number. Q is a rational, and if it is not a rational, we represent with Q bar now. So what are the irrational numbers here? Root 2, root 5, root 7, so on, along with pi. All these numbers are called as the irrational numbers. Now finally children, the combination of this rational and irrational are called as the real numbers. What are real numbers? Combination of rational numbers and irrational numbers. What are the real numbers? Real numbers is represented by R. What are real numbers, children? Combination of rational and irrational numbers are all called as the real numbers. Real numbers are classified into two types, rational numbers and irrational numbers. In rational numbers, we call them as rational numbers, whole numbers, natural numbers, integers are all belonging to the rational numbers. whereas irrational numbers other than p by q form are all called as the irrational numbers. So children, now let's start our first exercise in this textbook. Number system, first chapter, first exercise. Exercise 1.1. Look here, first problem. Is 0 a rational number? Is 0 a rational number? Yes, it is a rational number. Can you write it in the form p by q, where p and q are integers and q is not equal to 0? Where we have read the statement, children, here, p by q form rational numbers, any number which are in the form of p by q, where p and q are integers and q cannot be equal to 0. Those type of numbers are called as the rational numbers. So now represent 0. Is 0 a rational number? Yes, it is a rational number. How can you say? It is only one number it was there. It is a numerator only there. There is no denominator. But you can take how many denominators you want, you can take. So look here, 0 by 1 I can take, 0 by 2, 0 by 3, 0 by 4, infinite I can write this, right? So where this denominator should never be 0. Other than 0, any number it can be taken here. So therefore 0 is represented in the form of p by q and 0 is a rational number and q cannot be equal to 0. So finally what you can say, children? Yes, 0 is a rational number. It can be represented in this form. The second problem, write 6 rational numbers between 3 and 4. Observe here, children, is 3 and 4 is a rational number? Yes, 3 by 1, 4 by 1 you can write. So now how many rational numbers you need to write in between? 6 rational numbers, right? So I'm going to say you a technique. What is the technique? How many asked? That number you increase by 1. That will be 7. So you need to write 6 rational numbers. What you have done? 6 rational numbers plus 1 is equal to 7. Now take the numbers what given for you. 3, I may write it as 3 by 1 into what number you got here? Multiply numerator and denominator. So now numerators multiply by denominators. You need to multiply. 3 7s are 21. 1 into 7, it will be 7. So now what's your next number? 4. 4 can be written as 4 by 1 into what the number you got here, children? 7. 7 multiply. 7 4s are 28 by 7. So why we have done here, children? In order to find the 6 rational numbers in between 3 and 4. Observe here carefully. 21 by 7. If you cancel, what you are going to get? 3. 7 3s are 21. 7 4s are 28. This 3 a number we have written in the form of a rational number. So in between any 2 rational numbers, children, there are infinitely many numbers you can write in between 2 numbers. Okay. Now, what are the rational numbers? 6 rational numbers we need to write. So the rational numbers, the 6 rational numbers between 3 and 4 are, between 3 and 4 are, how you can write here, children? Write the rational numbers here. What are the rational numbers? After 21 by 7, see here, go on increasing your numerator. That is 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7, and last 27 by 7. See your children, 1, 2, 3, 4, 5, 6. There are 6 rational numbers in between 3 and 4. Okay, now let's see the third problem here. Find 5 rational numbers, children. How many rational numbers? 5 rational numbers in between 3 by 5 and 4 by 5. Observe that carefully. First you observe the denominator. Whether denominator is same or not, you see. If it is same, continue in the same process. If it is not same, it will be different process. Both I am going to explain here. Let's do first this problem, children. So what is here? How many numbers asked here? 5 rational numbers you need to write. Means 5 plus 1 will be 6. You have to keep in your mind. How many? 6. So now take the first number 3 by 5. Multiply for this numerator and denominator by this number. Okay. Now numerators multiplies 3 6 how much, children? 18. 5 6 30. Okay, 18 upon 30. Next number 4 by 5. What is the number you need to multiply numerator and denominator? 6. 6 4s are how much here? 24. 5 6 are 30. So the 5 numbers you need to write in between 18 by 30 and 24 by 30. Again, if you want, you can observe, children. If you cancel, you are going to get this one 3 by 5. You are going to cancel, you are going to get this as 4 by 5. Now, 5 rational numbers. Therefore, the 5 rational numbers between 3 by 5 and 4 by 5 are. Look here, observe here, children. From next to this number, numerator add, go on adding 1 and write the answer. That is 19 by 30, 20 by 30, 21 by 30, 22 by 30, 23 by 30. Observe here, children, how many you got? 1, 2, 3, 4, 5. These are the 5 rational numbers in between 18 by 30 and 24 by 30. That is 3 by 5 and 4 by 5. Suppose same question, if they ask you 8 rational numbers, what you are going to do? Denominator observe. If it is same, 8 plus 1, 9. Go on multiplying numerator and denominator by 9. Then similarly you are going to write. Suppose if your rational numbers denominators are different, how can we do, children, these type of problems? Children, let's take one example here, 2 by 5 and 3 by 2. This is not your textbook problem. Try to understand. Suppose if any question asked 2 by 5 and 3 by 2, between these two rational numbers, write 3 rational numbers I am asked. So first thing what you need to do, observe their denominators. Are they same, children? No, their denominators are different. So what we need to do? We need to try to make them same. How can you make them? This denominator multiply for this rational number numerator and denominator. And this denominator multiply for this number 5 by 5. So now write here, children, 2 2s are 4, 4 by 10, 5 3s are 15 by 10. Now observe here, in between 4 by 10 and 15 by 10, you need to write 3 rational numbers. Now your denominator same, no, children? So observe like this, you need to observe carefully. So now what is your next step? How many? 3, right? 3 plus 1 will be 4. Always try to increase one number. What the question asks, you need to increase one number. So that number you need to multiply for both numerator and denominator. 4 by 10, multiply 4 numerator and denominator. That will be 4 4s are 16 by 10 4s are 40. Okay, same manner you multiply this one. 15 by 10 into 4 by 4. 15 fours are 60 by 40. How much here? 15 fours are 60 by 40. Now what are the numbers you need to write here, children? In between 16 to 60. Any numbers you can take. Any number you can take here. Not only 3, 4 numbers. So you need to write only 3 rational numbers. You can pick any middle rational number you can write. That is 17 by 40, 18 by 40, 20 by 40, 35 by 40. Like this. Up to 60 you have a chance, children. In between these 2 rational numbers, any 3 you write. That's enough. So I am going to write the 3 rational numbers. The 3 rational numbers in between. You may write same number 2 by 5 and 3 by 2, as I will write this next number 17 by 40, 20 by 40. If you want, you may write it as 55 by 40. Any number you can choose, children. Please don't try to by heart this type of numbers. How to write, understand, any way you can write. So once you observe here, what is 2 by 5? 2 by 5 convert into decimal, it will be 0.4. Okay, then 3 by 2 convert, children, 1.5. So there are many numbers, many rational numbers between 0.4 to 1.5. So let's see here, 0.5, 0.6, 0.7, 0.8, 0.9, 0.10, 0.11. Like this, if you go on checking, you are going to have many, infinitely many rational numbers in between 2 numbers. So this is the technique, children. Once again I repeat, first thing what you need to do, if any 2 rational numbers given, observe their denominators. If denominators are same, how many numbers as that increase by 1 and do the problem. Suppose if denominators are not same, so what you need to do, try to make same by multiplying the opposite denominators. Okay, then after making your denominators same, then how many rational numbers you need to write for that increase one. Okay, now again multiply, same process. There is no change. Okay, so last main in this exercise, that is 4th main. Check whether they are true or false is your question. See the first question here, children. Every natural number is a whole number. What do you say, children? Every natural number is a whole number. Yes, whole numbers includes natural numbers along with 0. So in whole numbers, every natural number will be there. So what do you say for this statement? Every natural number is a whole number. Yes, it is true. Yes, every natural number is a whole number. Coming to your second statement, every integer is a whole number. Every integer is a whole number. Just think over here, children. What are integers? Whole numbers along with the negative numbers. Right? Suppose if any negative number, if we take -5, if you take, what happens? Is this a whole number? No, never. Whole numbers contains only natural numbers along with 0. But it does not contain any negative number. If any negative number there, that type of numbers, again it will be integers. So for this statement, what you say? It is false. Every integer is not a whole number. Therefore, they asked, is a whole number? It's not a whole number, right? So it is false. This statement is false. Coming to your third statement, every rational number is a whole number. Every rational number is a whole number. Let's look over here. So it is 1 by 4. 1 by 4 I have written here, children. It is a rational number. Does any rational number you have seen in whole numbers? No. Whole numbers will be having only natural numbers and 0. So this rational number can never be a whole number. So what you can say, children? This statement is also false. With this, we are going to end our exercise. In our next session, we are going to continue this chapter, children. Thank you all.